My name is Akash Bhatti, Section Astrostat, USN 1VE23EC003, Subject Dsdv. Today we are going to discuss about the deriving the truth table from problem statements. Truth tables are a powerful tool for analyzing the logical relationship between different variables in given problem statement. By systematically listing all possible combinations of inputs, values, and their corresponding outputs. Truth tables are provide a clear and concise way to understand the underlying logic of problems and derive meaningful conclusions. What are truth tables? A tabular representation. Truth tables are a tabular representations of the possible inputs and output combinations for a logical operations or a set of logical operations. Mapping inputs to outputs. They systematically list all possible combinations of input values and the corresponding output values, providing a clear visualization of the logical relationship. Identifying logical patterns. By analyzing the truth tables, you can identify patterns and logical connections that may not be immediately apparent from the problem statement alone. Why are truth tables important? Understanding logic. Truth tables provide a systematic way to understand the underlying logic of a problem, making it easier to identify and address any logical inconsistencies or contradictions. Optimize solutions. By analyzing the truth table, you can identify opportunities to simplify or optimize the solution, leading to more efficient and effective problem solving. Verification and testing. Truth tables can be used to verify the correctness of solutions and to thoroughly test the various inputs and output scenario, ensuring the reliability of the final outcome. Identifying variable in problem statements. Identify relevant inputs. The first step in deriving a truth table is to carefully analyze the problem statement and identify the relevant input variable that will determine the output. Recognizing logical conditions. Look for any logical conditions or constraints that are mentioned in the problem statement, as this will help you define the possible combinations of inputs and their corresponding outputs. Determine outputs. Once you have identified the input variables, determine the output variables that are dependent on the inputs and will be focus of your analysis. Understand the context. Consider the broader context of the problem to ensure you are capturing all the relevant variables and logical relationship. Constructing the truth table. Arrange inputs. Start by arranging the input variable in the columns of the truth tables, with each column representing a different input variable. List all combinations. Systematically list all possible combinations of input values, ensuring that you cover the full range of possible scenarios. Determine the outputs. For each combination of input values, determine the corresponding output value based on the logical condition and relationship defined in the problem statement. Analyzing the truth table. Identify patterns. Carefully examine the truth table to identify any patterns or relationship between the input variable and the corresponding outputs. This can reveal underlying logical principles or simplifications. Detect contradictions. Look for any contradictions or inconsistencies in the truth table where the output value do not align with the expected logical relationship. This can help you identify and resolve any issues in the problem statement or your understanding. Optimize solutions. Use, use the insight gained from the truth table to identify opportunity for optimizing the solution, such as simplifying logical expression or reducing the number of required inputs. Problem statement 1. An electrical motor powering a conveyor used to move material is to be turned on when one of two operators is in position. If material is present to be moved and if the protective interlock switch is not open, input and output variables are to be expressed in binary, that is, If operator 1 is in position, then the associate variable is a logical one. The motor is running if its output control variable is a 1, and the motor is off if the variable is a 0. Figure 1.3 shows the simple diagram of the conveyor system. The first tank is to identify the input and output variable to assign names to them. Solution. Variable A and B identify that the two operators are in position A. Operator 1 is in position B and operator 2 is in a position. Let the motor variable be signified by M and the interlock switch be specified by. If the interlock switch is closed, then S is true. First, let the material present variable be M. M is the capital M is the signal to turn the motor on and off. S means interlock switch is closed. M means material is present. A, B, S and M are input variables. Capital M is an output variable because 4 input variables exist. We know that 16 combinations can occur. 2 power 2 2 power 4 is equal to 16. The truth table describing the inputs. Output relationship is listed in table 3.1. To turn on the motor, one of the two operators must be present. Material must be present and the interlock switch must be closed. Such system may be found in any number of industrial environment. The actual control may be implemented in any number of ways. The actual means of implementation is not important. For now, what is needed is a developmental picture of process of converting a written problem statement to a truth table. Evaluate the truth table. Notice that the following set of switching terms causes the output M to be logical 1. Each element in the set of conditions that causes the output to be a logical 1 is a term in the output equation which is written MABMS, ABMS when either one or both of the two operator represented by a variable A and B is present. Material is a present and the interlock switch is closed, then the motor represented by the output variable M is started. Here is the truth table. As the input A have the values of 8 zeros and 8 1 and input value of B is 0 0 0 4 0 4 1 and 4 0 and 4 0 4 1 and input value of M's and input all of S and the output of capital M. When we put the input values of A, B and MS 0 0 0 we get 0 value. Same as that we should put the values of according to the other inputs as given in the truth table. Industrial problem or automating order fulfillment. In the e-commerce industry, order fulfillment is a critical process that determines the success and customer satisfaction of an online business. Automating this process can significantly improve efficiency, reduce errors, and enhance the overall customer experience. By deriving the truth table from the problem statement, we can identify the key variable and optimizing the order fulfillment work. Identifying variable in order fulfillment. Input variables. Order placement. Payment method. Inventory availability. Output variables. Order confirmation. Shipping details. Delivery status. Logical condition. If order is placed and payment is confirmed and item is in a stock, then confirm order and provide shipping details. If order is placed and payment is confirmed but its item is out of stock, then notify customer and provide estimate delivery date. Building the truth tables. Optimizing the order fulfillment process. Order placement. Streamline the order placement process by integrating online phone and in-store channels into a unified system. Payment confirmation. Automate this payment confirmation process to quickly verify the order and move it to the next stage. Inventory check. implement and real inventory tracking to instantly determine item availability and provide accurate information to customers. Order fulfillment. Automate the order fulfillment and shipping process based on the available inventory, ensuring timely delivery to customers. Customer communication. Streamline customers' communications by providing accurate order confirmation, shipping details, and delivery status. Thank you.